Hi, and welcome to the first webinar in a series that will focus on the opportunities that streamed XR is bringing to the manufacturing industries. My name is Felicia La Jakobsson, and I'm the Deputy Process Manager within Visual Sweden. In a series of live and on-demand webinars, we will present thought-leading experts from technology companies and research groups working in the forefront of XR. The webinar series is hosted by the Visual Sweden project, Augmented Operator, which aims to explore solutions for empowering the operators by the use of visualization techniques, such as augmented reality. Visual Sweden is an innovation initiative aiming to develop Europe's most attractive innovation environment for visualization and image analysis. We do this with our around 100 partners, where the core is, of course, the developing companies together with Linköping universities and other research institutes. With me today, I have the Augmented Operator Project Manager, Thomas. Hi, Thomas. Welcome.
Hi, and thanks for having me here. I'm very excited for this first webinar in the series. My name is Thomas Rydell, and I'm a co-founder of a Swedish visualization company called Interspectral. And I'm also the product leader for this project, Augmented Operator. And as Felicia mentioned earlier, we will in this webinar series invite a number of experts that will give their perspectives on XR for manufacturing industry. The first topic that we will talk about today is streaming of XR and what that means for the manufacturing industry. For this team, we have invited Greg Jones from NVIDIA, one of the supporting partners of our project. We're very excited to have Greg here today. Before we will hand over to Greg, I will just give you a brief background of Greg, because he's been working in many interesting areas. So Greg is the senior manager of global business development for XR, and he's also the product manager for CloudXR. Greg team focuses on partnerships and projects that uses NVIDIA's professional XR products. And before coming to NVIDIA, Greg was the associate director of a research institute focusing on scientific computing and data visualization at the University of Utah. So now I will hand over to Greg, and after the presentation, we will have a discussion about the topic of streaming XR, and specifically then for the manufacturing industry. So yeah, I'm very happy to give you Greg.
Thomas, thank you for that introduction, and let me jump right into my slides on this talk about streaming XR. So first off, what I want to talk about is the difference between professional XR and its requirements and what we usually associate with XR, which is the gaming XR or consumer XR. So some shared parameters. Everybody wants to be in photorealism, so the better the graphics, the better the experience. Both consumer and professional need high frame rates, right? Without the high frame rates, you end up with that XR, VR nausea. And then field of view, right? We all want to immerse, whether we're playing Half-Life Alyx or whether we're working in a VRED design review. We want to have a full field of view so we're really immersed in that experience. Where professional deviates somewhat and amps up the requirements relative to consumer is the fidelity of our models, for one thing. So if you're doing a design review, you want the entire data set in your system. You don't want a decimated data set. You want entire digital twin, per se, to be that visualization. You also want XR not to be just a standalone application. You want it actually to be part of your pipeline. So if I'm working in a factory and I'm working in a digital twin in VR, that's part of the whole flow of production, all the way from design engineering, design review, all the way to marketing. So your XR tools now have a demand of not just being an instance, a one instance game. They have to be part of a production pipeline. And then what we see in consumer versus enterprise is a absolute increasing demand for resolution, right? So the better the resolution, the better the experience. We're looking at detail when we're doing design review. We want our training to be in a simulation that takes us as close to real life as possible. So our muscle memory that we're training is accurate. All those things, resolution is key, and photorealism. And that idea of high fidelity and high resolution in the headset or in the device, the end device, really puts significant demand on XR, delivering XR. So just looking through the use cases, I've listed a few here: manufacturing, training, entertainment. We're right now at the point where the software companies, the ISVs, are really putting out valuable products. And there's no better example than this than in the training domain. And so this next slide, what I'm showing is a study that was done, and I pulled this out of a National Institutes of Health, one of the US government research groups database. And this is just one of many basic studies on training XR and the value of training XR. And what they're finding in these academic studies is the knowledge increase, the knowledge base is significant relative to people that train with old methods, non-immersive. So immersive students are getting a better training event by a significant measure. And that means they know more about their subject when they're done training immersively. They get on the shop floor. So in this case, this is a piece of training where medical students learned how to do a shoulder surgery, basically expose the shoulder joint. And what they showed with this is the students understood the surgery better. They were able to do the surgery in real life sooner. And when they did the surgery, they were faster and a higher quality cut, right? So what we're seeing in training is a real return on investment for companies going into immersive training relative to the older methods. So training is kind of what I think of as a breakout piece of this XR marketplace. And we're seeing, design review and a variety of other places follow along. But training really has shown that this immersive environment is critical to enterprise and really valuable to enterprise. It's important to remember that when we talk about XR, when I talk about XR, I'm thinking of very high fidelity VR and AR experiences with photorealism and everything you can think of. That market of high fidelity VR is relatively young. I think of it, because I'm with NVIDIA, I think of it in terms of graphics cards generations. So it's only been about 3 generations, and I show those here on this slide. So the Maxwell, the Pascal generation in NVIDIA speak, and then our RTX and Ampere generations. So there's 4 generations of cards where we've really had these VR ready graphics cards. So it's important to remember that the graphics cards keep getting more powerful, but along with that powerful graphics card, the market demands more resolution, wider field of view, more model complexity. So there's this give and take in the market, but it's a relatively young market. And we've been through, the big part of the hype cycle, the hype, the period of disillusionment, as they say, and we're really now gaining on that real market use and traction. But this market is really brand new in the terms of tech markets. So when we think of the quality demands on enterprise and we think about these big graphics cards driving this, one of the requirements for VR in this case is you have to be tethered to a workstation. This tether delivers this high-powered graphics card to the headset. That's great. But as I've shown in these 3 examples here in this slide, this left-hand example is the Bell helicopter team doing some ergonomic studies in one of their later helicopter models. What they found during these studies is they saved literally years and millions of dollars of physical prototyping time in their design of this helicopter. They had the pilots come in and really understand the ergonomics before they ever cut a physical prototype. What you see in this image is I've painted the tethers red and I've put an arrow in there. And that's that tether that hooks that headset to a high-powered GPU to do those high-fidelity models and such. Surrounding this scene is, lighthouses for our tracking, the workstation, all the cables that go with that. So this tether represents not just a connection to a machine, but also how difficult it is to get into tethered VR with setting up the tracking system. So what you see in engineering firms and architecture firms is if I'm going to use VR, I need a VR expert to come in, set the system up. I need to get my data transferred to that system. So the level of complexity to get into VR is a pretty significant barrier. Now, this middle panel, excuse me, shows a filming of a Mercedes-Benz commercial a couple years ago, done by the Neuralizer group and the Alert Studios. This cameraman is tethered to a headset, and you see he's actually got someone managing that tether for him. The problem with this scene is it turns out to be a great commercial. I encourage everyone to go look it up. It's on YouTube. As the cameraman moves around, and you think the cameraman wants to use natural movements in this incredible simulation, the tether is only about 15 feet or 3 meters long. And so what happens is he can't actually move around the entire car. So he has to limit the physical movements he would usually have with interacting with this car, with this digital model. He has to accommodate he has to accommodate the tether and change those movements. And to the right-hand panel is an extreme. This is Steven Spielberg directing the movie Ready Player One, and a great experience, according to him. And you can see all the complex equipment that goes into the setup, but you can imagine a director trying to do a live action scene in VR that, again, that tether, all that equipment is going to limit his natural interactions and basically change the way he does his job. So the tether's required for high fidelity, but it really represents a limit of the XR technologies. And those are kind of hard limits I spoke about. In this graphic, what I want to show, it's a little mock-up, but what we're doing with XR, when you go into XR, and I've had this experience a couple times, is if you're in there long enough and it's a high enough fidelity setup, you are actually fooled. You actually think you're standing with a real car, for example, in a nice design review package. And so you've gotten into this magic spell of XR. You actually believe the scene, and you're immersed in your job. You're doing design review. You're discovering things, and then you hit the end of this cable, and that magic spell is broken, right? So the tether limits your natural movements. It is hard. It represents a fairly complex system to get into VR, but most importantly, that huge value add of XR of putting us in an environment where we believe we're actually in that environment doing our jobs. When you reach those physical limitations, whether it's teleporting around or actually having the cable tug on your head, that really breaks that beautiful immersion we can create with XR. So nowhere is this better realized than in collaboration. So this is a scene from NVIDIA's holodeck. It's a collaborative environment we built a couple years ago to really push the boundaries of what we thought we could do collaborative XR in. But when you did collaborative XR co-located, right? So remote collaboration, maybe not as big a deal, but co-located collaboration, you had to watch for each other's tethers. So as you moved around the room, we were tripping on each other's tethers and such. And so for collaboration, which is a huge value add for AR and VR, the tether, again, is a real limiting factor. And then, you couple that tether and the difficult to get into environment, and you look at some of the relevant market data, the market trends right now. This is some data from Statista Inc. on their webpage. What these charts show is the growth, the sales of HMDs, right? So how many units were sold over the 2017, 18, and 19. I'm going to focus on 2018 to 2019. What you see is overall HMD growth. It's a nice, robust 32% year to year annualized growth rate. That's a great growth rate. It's if I had a stock that did that, I would never invest in anything else. But for a new market, it's relatively organic. So if you dive into these sections of these columns, what you see is this all-in-one, this black 0.9 to 1.7. That's the all-in-one market. So if you look at that annualized growth rate, even though it's a really small sample from 2018 to 2019, and this is partial 2019 data, we see a 90% growth rate. And that's mostly Oculus Quest 1. Now, Oculus Quest 2, we already know it's surpassed Oculus Quest 1 sales. So this growth rate in the HMD market, that 30%, is really representing a 90% growth rate in the all-in-one. So the all-in-one market is really getting on this kind of this growth rate we all expected XR to have, this adoption rate. And it's because, you know, the all-in-ones, you just put the headset on, you're in the environment, you're in your menus right away. There's no outside trackers to set up. You don't have to have a huge workstation with you. And it's just an easy experience to jump into. And so these all-in-ones are changing the market, and their growth rate is really accelerating XR adoption. There's obviously some limitations with the all-in-ones. And so in this slide, what I'm talking about is basically they're easy to set up. That's great. They have a great freedom of movement. You're not tethered to anything. There's no demand of a high-end expensive workstation sitting right next to you. On the other hand, you know, the GPU you tether to is about a 300 watt GPU. The GPU in the headset, the Oculus Quest 2, for instance, has an XR2 from Qualcomm. That GPU is maybe a 3 watt GPU. And so obviously with a 3 watt versus a 300 watt GPU, you've got some limitations in how powerful that GPU is. So you have limited processing power. And I got to say, we work really closely with the Qualcomm folks, and we're optimizing with their XR2 chip, and it's an amazing SoC. So don't let me say anything bad about that. It's really a quite stunning chip. But relative to a full GPU, a full, you know, data center or data workstation GPU, the limited memory is an issue. So we, you know, the new Ampere 6000 has 48 gigs of frame buffer. The Adreno on the Snapdragon has, I think, a gig. So limited processing power, limited storage, because you have to have it on a headset. It has to be mobile. It has to live on a battery. All those things means you have limited model and limited graphics fidelity in the all-in-one. So we're at this cross section of what enterprise needs, but also how just a really good experience the all-in-ones have. How do we bridge this cross section, this desire for full fidelity models, the world's best graphics, all that type of stuff with this mobility? That's the question we have now is how these enterprise use cases can get to the best of both worlds, high quality graphics like represented by the A6000, or the mobile freedom represented by all these different end devices, including tablets and phones and such. And that's the vision behind what we've created in CloudXR. So the idea is, let's stream from a data center. So over here on the left-hand side of this slide, I have, you know, my XR content sitting in at NVIDIA, it's RTX or EGX servers sitting in a data center, sitting in an edge somewhere, and then streaming over a network to these all-in-ones. We actually demonstrated CloudXR about a year and a half ago at Mobile World Congress in LA. So this video that I'm going to play, this is a McLaren Senna. It's a 30 million polygon model, and it's being rendered with Autodesk VRED. And we're showing this video comes from a Samsung 5G S10 phone. And obviously we're not running Autodesk VRED on the phone, and the phone couldn't render this beautiful lighting and model if we could. And when I zoom into the steering wheel here, you'll see the detail of the full model being rendered. So this is the full 30 million polygons. Where it's being rendered is in an RTX or an EGX workstation in a downtown Los Angeles data center, a Verizon data center, and then streamed over Verizon's production 5G network and down to the show floor in Sean Wagstaff's cell phone here. Sean is the guy that built this demo. And so that's the idea of streaming XR, is full models, lightweight end devices, and using networks like the 5G networks that are up and coming. And it's a really exciting thing. So when we think of AR and VR in these spaces, I just want to show some of the graphics differences. So on that left-hand panel, what I'm showing is, you know, this is when we're in a training environment and we want full resolution text. This is what we have when we think of full resolution text. On the right-hand side is a full headset powered by a full graphics card, and then the left-hand side is kind of what you'll see in your all-in-one experiences. So if we're training in these environments, working in these environments, we want to see the real environment, we really need that resolution increase that the graphics cards, the heavy-end graphics cards can produce. On the right-hand side, what I'm showing is a scene from ESI. This is a company that authors software called ICIDO. Those two gentlemen, one's wearing a HTC Focus Plus, one's wearing an Oculus Quest 1. They're in a collaborative, co-located collaborative session, and the model they're looking at is being rendered in a data center with 70 million triangles with photorealism, and they're able to just move around that model freely with no tethers. And that's the type of experience we're talking about. In the middle panel, I'll zoom in on this. When we think of AR on the phone, like I showed in the slide, we think of Pokemon Go is the typical AR thought we have. And you look at the graphics, and they've put some shadowing in with Pokemon, with Pikachu, and that's great. But compare that to, this is a Rimac, a new EV that's coming out on the market, that's being shown in the NVIDIA headquarters lobby. And that car's not actually in the lobby, obviously, but you can see the lighting effects, the shadowing effects, and all the detail of the model. That's what we're talking about when we think of streaming. The increase in quality of the graphics is really extreme. So I wanted to show these just because it's hard to imagine what I'm talking about. When we start moving the actual delivery platform of XR from a workstation to a data center, now we also have the flexibility that data center delivery brings. So now, with virtualization of the GPU in the data center, you can serve your CAD models, you CAD modeling programs, your desktop programs, everything, and then you just essentially add XR onto that workload that you've already got in the data center. So it really makes a flexible delivery system. So I think the thought of streaming from different edges, whether it's the telco edge, from the data center, from the cloud, what this represents for the industry is actually changing the distribution point of these XR packages, and that into virtualized systems where ISVs now can reach millions of users and not be dependent on each user having a dedicated graphics card at their desk side. So this is really part of that VR revolution, XR revolution that's coming. So changing the distribution model from one-to-one GPUs to one-to-many is really the next step in delivering these software packages. This is a quick overview of the architecture of CloudXR. It's an SDK that's available on the NVIDIA DevZone website, and it has your VR application. Right now we have an open VR interface. So your VR application just sits on the server. We give you in that distribution a binary to sit on the server. That's the driver. It's a built on Steam VR. So your open VR application sees Steam VR, hands Steam VR a frame. That frame is taken by our library, transported over the network onto a client application. And in the SDK package, we have a variety of clients that are come with source code. So you can actually take those clients and modify them to fit your use case, fit your HMD, whichever. And so we receive the frame in that client, we decode that, we hand it to the HMD. Now this is the really nice part, and there's a variety of software systems out there that do this, not just CloudXR, but this is the way we've built it, is when we hand the frame to the HMD usually calls for a late frame warp. Some people call it late latch, asynchronous time warp, whatever. What is happening is you're well past your 20 millisecond turnaround that you need for, let's say, nausea-free XR experiences. So in order to accommodate the extra movement that the headset has gone through, the headset says, hey, I've moved since I gave you that frame to render. Will you move that frame over and fit my current location? And so what happens is the HMD basically calls Steam actually calls a late warp from the GPU. The GPU moves that frame over, and the user is not aware of the fact we've missed the latency period. And so instead of going back all the way to the server side GPU, CloudXR just asks the GPU on the client side to do that late latch. And so what we've done is we've put late latch on this client side GPU. Late latch takes anywhere from 1 to 3 milliseconds, that late frame warp. And so the user, as far as the user's seeing, they're seeing a 3 millisecond old image, fits well within the 20 millisecond range that we need to hit to not induce nausea. And so we've covered up all that latency of render, encode, decode, network transport, some buffering we do. and the user gets a great experience, even though it's taken quite a while to get that frame to them. This is a little deeper dive into that architecture. And so what I can show you is over here on the upper left-hand panel, there's the VR application, the VR runtime. It talks to the open VR interface in CloudXR. We encode that frame here, and then we stream that frame over. And these streaming libraries, this is kind of the technical piece of CloudXR. NVIDIA has had a program going for a while called GeForce Now, and it's our game streaming service. We have data centers around the world streaming high fidelity AAA games to gamers, and it's the same idea. Not everybody needs to have a 3080. They can have a GeForce Now account and play any game on any device. And so those streaming libraries have been in the works for 6 or 7 years. We've adopted those to fit the XR experience. And so those are the streaming libraries sitting under CloudXR. And then so we get that frame from those streaming libraries, we decode it, we actually buffer it for a second. And this buffer is to accommodate jitter so that we can make sure we have the full frame assembled. And then we hand that frame to the VR runtime. The VR runtime requests that late latch. And so that late latch is done here, and the user's not aware of all the latency that was incorporated in getting that frame to them. And if you think of latencies, we've got, 10 milliseconds minimum for the frame render. We've got, let's say, 10 milliseconds each for decode and encode. So we're 30 milliseconds lag already. If you put a 10 millisecond network in there, which is a pretty fast network, you're at 40 milliseconds of lag already. And then we buffer for about 8 to 10 milliseconds. So we're 50 milliseconds, depending on your network, and it can go up and up and up if you have a lot of jitter or if you have a long latency. And so we're covering up quite a bit of latency in here. And what we've seen in CloudXR just empirically is if we have 100 milliseconds of total latency, it's still a really, really good VR experience. So that gives you some pretty interesting networks you can work on in the CloudXR space. And so thinking of what that system allows you to do is now we can run XR in the cloud, from an on-prem data center, from a local workstation, even from a VR-ready laptop, and stream it over a variety of networks. 5G, of course, is the penultimate. We've seen some really nice trials on low latency, high bandwidth 5G networks. It streams over Ethernet, so you can think of hard attaching lightweight clients, tethered to heavy duty headsets. And then, of course, it streams over Wi-Fi. Wi-Fi 5 has some conundrums in the fact that if you get too many users in there, you see a lot of jitter in the network, and that creates an untenable solution. So Wi-Fi 5 is not the best. It works. It's what I use in my household. Wi-Fi 6, we've seen some really interesting results with multiple users on Wi-Fi 6. So, the thing to keep in mind from this slide is there's multiple ways to deliver CloudXR from multiple regions. And I want to mention on the cloud, we've done some testing with AWS. So we've been in beta with a couple ISVs. And the AWS, streaming from AWS regional data centers is really quite robust. One of the AWS colleagues actually played the Alex Half-Life for a while using one of these with a 30 millisecond, 40 millisecond connection to a data center. So it's a really amazing that it can be done, and it's really an amazingly good experience. We're all shocked that we can stream XR from a regional AWS data center. Where CloudXR is going, where this idea of being able to stream from data centers, because as soon as you're streaming from a data center, you get access to a lot of compute. So you can think of, future type of stuff, mixing AI workloads now that you have all that compute in a data center. So putting AI and XR, mixing the two, split rendering, where you start doing some ray tracing of certain items, or maybe whole global illuminations that you share with a group in the same scene. Just a variety of things open up now that we're streaming from high-end compute systems in data centers. And with that, I'll go ahead and mention that we have a ton of partners we're working with. They're all great. I'm sure these slides will be online. And so take a look at the partners, contact them, ask them to work with CloudXR. But I want to thank them just for all the great work they're doing with us. And I'll close it out there. And encourage you to go, test CloudXR. We're at the 2.0 release. There's a bunch of great talks at GTC about it. So, show up for those, and I'll close out with that. Thank you. And thanks for the time. Thomas and Visual Sweden, thanks for letting me run through this presentation.
Thank you, Greg. Thanks. Thanks for a great presentation. It was very interesting to hear some basics about streaming and also where you are with CloudXR. So we can continue the discussion with some questions. So we have all seen that XR have been around for a while, and we have seen like several hypes during the years. You have a long background in data visualization, right? So we have seen the XR coming and going, but the technology really didn't get mainstream. So why do you believe it's different this time?
Yeah, it's an interesting story. So I was at the University of Utah for the last 20 years working with the visualization group. So I've been in the viz game for a long time. When Dave Weinstein, the director of XR at NVIDIA, called me up and said, "Hey, you should leave the university and come work with NVIDIA and we'll do VR together." I said, why would I do VR? VR is horrible, right? And this was right around when Maxwell came out. So this was only 4 years ago. And he said, "No, come over, we'll go through VR Funhouse and we'll see a VR experience." And so I went through the VR experience and it was like, wow, this is really incredible. I'm shocked it's gotten this good so quickly. And so that's to that point of the one slide I showed with the GPUs is the market's really young. It's 4 years old. Everybody thought VR was going to take off like a rocket. But as I mentioned, VR systems are relatively complex and hard to get into. But we've seen some really nice recent data on like the training systems being just a huge value add, the design reviews taking off. So I think we've kind of crested that period of hype and we're actually into the solid market growth. And like I said, those all-in-ones, we're seeing 90% year-to-year growth in the all-in-one market. So I think XR is finally to that point where we're going to see market growth, maybe not what we hyped, but a really significant market growth that shows a high value ecosystem. And if we can really get the high-end fidelity experiences in these all-in-one headsets and make that norm, I think the user growth rate will just really stay in that exponential space.
Great.
So I think we're right on the cusp of the growth now.
So then on to streaming, and so streaming has the recent years been a very hype technology as well, and we see like the big companies like Microsoft and Google and so on, they use streaming to power like virtual desktops and stuff like that, but also consumer apps like gaming and so on. So why do you think that's happening now, and why is that shift important?
That shift is important because so our CEO says everyone's a gamer, just not everyone has a 3080 desktop sitting in their gaming studio. So the idea behind GeForce Now, for instance, is let's give all the hundreds of millions of people that want to play these high fidelity AAA games access to that graphics card through streaming. I think the same market movement's going to happen with XR, where if we can stream and Microsoft just announced Mesh, which is a gorgeous looking system. We're working with AWS, hand in hand. We're working with the other CSPs. I'd encourage everybody to see the announcements at GTC. I won't out them before they're ready, but it's the same idea. Now that people don't need that complex setup, they don't need a VR technician to help them get into VR. The streaming is a really important new distribution model for all the ISVs that will end up on these edge compute systems delivering to one to many. And so it's just that everyone's an XR user, they just don't have access to an XR system. And now for with the Oculus Quest 2 for $300 and the right software, you could stream a high fidelity use case. So everybody can be an XR user now. So I think that's the importance of streaming, is changing that distribution model of the XR software. And that's, I think it's just going to really accelerate the market.
Yeah, I totally agree. It's very exciting, and it will hopefully make this type of technology very accessible for both consumers and for enterprise users. So we have this project with some big Swedish enterprises involved, and they have, I think most of the companies involved in the project have done some proof of concepts of using AR and VR in the companies. And perhaps it was some years ago. but they never made it into production. This seems to be a quite common situation where companies do proof of concepts, but it do not end up in production. So do you have an idea why that is, and why it could be different now?
Well, I look at architectural firms as an example. So the typical architectural firm today that has adopted XR to some degree, they'll have a special room or maybe 2 rooms or a special workstation down the hall that is the VR workstation. So I'm an architect, I'm sitting at my desk. Going into an immersive environment is really something, because you get to see everything at scale. It's always hard to imagine a 40-foot wall, but if you go into VR, the 40-foot wall is 40 foot or 10 meters or however we want to put the units on it. And so, but right now, if I'm an architect, to do VR, I have to get up, I have to leave my desk, walk to the VR room, ask the VR technician to set me up. And so that's a significant barrier to putting VR in my day-to-day production workflow. And so everybody's busy. Like if you talk to the design engineers at Audi, their schedule's full. They have a full, work week already. And to say, hey, don't go to the clay model, instead go to the VR cave and get in an immersive environment and break your day up. That break in that time, they're already busy. They just don't have the extra time to adopt a new technology. Now, if I can move that headset to their desk and they can just jump into that environment without that heavy lift, I really believe, our on our way to change the clay model and eliminate the clay model, which is a grail for XR, we have to make that clay model at everybody's desktop, right? So here, put the goggles on, you can see the clay model. It's beautiful, it's fidelity. You can see everything you used to see when you walk down to the hall to go to the clay model. And now if you want to do a collaborative session, just tell everybody else in the factory to pop their goggles on and you can have a collaborative session. And it will actually save you time now. Instead of having to go to the VR room and go to the clay model, now you can just at your desk put the headset on and be in with your colleagues in whatever environment you want to see that model in. So I think this distribution from the data center and making it easier to get into AR and VR is really the key to that adoption in production, because production is already so busy, so optimized that if you're going to break into it, you can't cost any time at all. And XR costs time right now.
Okay, it's a good answer. I think also the accessibility will make it more successful. So we talked about this a little bit in your presentation, but what would you say is the most interesting application for AR within manufacturing today? So you were into training, but could you point out some other good examples of?
Yeah. So I think the coming examples of, let's say you're on the manufacturing floor and you're looking at a part, right? So having that part image analyzed from an AR headset in the data center, have it part checked, a quick quality scan on it, and it tells the worker, hey, this is the right part and it doesn't have any defects, go ahead and use it. That type of on-demand QA QC will be really valuable. Also, an upcoming demo that we'll show it relatively soon will be a design engineering team handing their design to the manufacturing team through a 5G wireless VR system. And so that communication of disparate engineering groups, the manufacturing floor saying, hey, we're putting this into manufacture. We have a couple questions. Can you hop into VR with us? You don't have to drive over to the factory. Just put your headset on. We'll put our headset on. We'll go into a collaborative session, work through this problem we're seeing. Those use cases, those kind of collaboration use cases will be the next big thing. And I think, the value, I see 2 primary value adds of VR. One is that you can be in a system at scale. So, that's especially important in design review and architecture. But also you can be in there with other people. And so if I'm an engineer in Germany and I'm helping the plant in Austin, Texas, build a car, and they have a quick question for me, We just have to put our VR headsets on and go in the environment together, look at the question, solved, and no one has to get on a plane, and it's quick and easy. And that's, lowering that barrier to entry to get into the VR experience really enables those quick collaborations from factory floor to design engineer and such. And I think those use cases in manufacturing will really blossom over the next couple of years.
Great. So, yeah, we have all read them. There are some big rumors about like the big companies, for example, Apple are planning to release like new consumer XR devices. We have seen pictures and stuff, but we don't know what they will release. But what do you think will happen with the XR market and AR market, both for consumers and for enterprises, when a company like Apple release a consumer device?
Yeah, well, I think there's two pieces of that, and we're seeing it a lot with Oculus, right? So Oculus is solving some really interesting problems. HTC is also with the all-in-ones they're creating, right? The market demands resolution, so nobody's going to put out a lower resolution device. We'll see field of view become more and more important in the AR devices. But then we get into, so the technology will keep resolution going up, field of view going up. Those will be, and ease of use will go up. So those three things I think will be the market focus of the new headsets coming out, whether it's an established group like Oculus or a new group like Apple or the AR devices like the HoloLens and such. The interesting thing, and Oculus is demonstrating this better than any academic group can, is how do you mix the models when you want to license to both consumers and enterprises? Right, so the demand to have a Facebook account to use Oculus Personal, the Oculus for Business model, the Oculus for Business model actually works really well. We're using it inside of NVIDIA. We're really happy with what it offers. But putting those marketing models out and having everyone understand them is really a leap also. So not only will we have a change in technology, but we'll see these licensing models, the communication of the models, the adoption of the models, be part of the learning curve of everyone using XR. And so it'll be really interesting to see, the new entries, the larger companies come in and put headsets in and what distribution models they'll use, right? So for instance, putting a streaming app on iOS, on a iOS application page, the Apple apps is not licensable. So things like that will need to change. So there'll be some of the challenges for the distribution models to change also along with the headsets. So like imagine a future with headset. Do you think we will have the same adoption with headsets as we have seen with smartphones? Like what do you think, like personally? That's a toughie, so I think of I think of my sunglasses versus my cell phone. So my cell phone is always with me. It's always in my pocket. My sunglasses, which, if I had a great AR device or VR device, it would be just like my sunglasses. I leave my sunglasses all over the place, right? So I'm constantly leaving them in my truck or at a restaurant. And so less so with my cell phone. So I see a lot of adoption. I see as we get lightweight devices that allow for really interesting social experiences, I see great adoption. It's hard to imagine as widespread and as high utility as the cell phone. So somewhere near that, but not quite, is how I see it, because the cell phones become, essentially part of us.
Yeah.
And my sunglasses, I really like them. They're really expensive because they're prescription. I still lose them more than I lose my cell phone.
Okay. So I think I have one more question before we round off. But so what do you say is your best advice to companies, enterprise companies in manufacturing looking to explore XR? Do you have any advice, like how to start and where to start?
Yeah, I think there's a variety of companies to contact. We have a person in our group that actually works with ISVs. So you can contact me and I'll hook you into sharing NIMS who will help you understand the ISV environment, who's offering what to manufacturing groups. HTC has a huge push in industrial use cases. So if you have an HTC rep you work with, that's a great place to go. The Magic Leap team is working really hard in the enterprise space. And we have contacts to all these teams. So I would say, first step, just shoot me an email. I'll introduce you to our person managing the ecosystem for us, and she can line you up with ecosystem partners to help you understand what they're doing for your use cases.
Awesome, that sounds great. Thank you, Greg. So yeah, thank you for participating in this webinar. I know you're a busy guy and preparing for GTC, so I'm grateful that you took your time. And sorry for us screwing up the time zones. But thank you very much. And also to our listeners, I would say that this was the first webinar in the Augmented Operator webinar series. And we will, during the coming year, release some more interesting speakers that will give their unique perspective on XR for manufacturing. And you can just check out the Augmented Operator website for more information. So that was everything for us. Thanks again, Greg. And thanks for you listening. Okay, take care. Bye-bye.
Bye-bye.